Okay, so as promised, here's the little video that goes along with the predicting ions worksheet, especially for those of you gone when we did that in class. So hopefully the front side of the worksheet where you were just doing more main group element charges was relatively easy. And this is where it starts to get more complex. You might remember at the beginning of the year, we talked about transition metals having multiple charges, that you had to write the charge as part of the name. Now we're more looking at why they do what we do, because we love a why question. So I'm just going to do a couple of examples, and then hopefully you can extrapolate from those examples to figure out a variety of charges. So it's important when you're doing this to look at the electron configuration, in particular of the valence electrons, so the last energy level of whatever element you are interested in. So let's look at silver. And silver and gold and copper are all going to behave somewhat similarly because they have similar electron configurations. So I'm going to write my electron boxes. So here's the s orbital, and then the d, 5 boxes. So if we're talking about silver, we're talking about the 5s and the 4d, and that part is less important than just looking at where the electrons are located within those boxes. So silver has 2 in the s and then 9 in the d. Okay, so I'm going to make those green for fun. 2 in the s, 9 in the d. And of course, when they fill up, they go up, 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 and then down. But I just did them speedily. Okay, so the 4D here is very close to being all the way full, right? There's just one space missing. And having a full D is a very stable situation because there's so many boxes. So one of the things that happens with transition metals is that they sometimes can move electrons around a little bit in order to fill up a D or an F orbital. Will work the same way. Remember that they are metals. Metals always lose electrons. Think back to the beginning of the year. So these are all going to be cations. Silver can't gain one to fill that spot, but it can do something else that is interesting. So what's going to happen is one of these s electrons, that guy right there, is going to get sort of bumped up to fill in that gap. Okay. So he's moving, going to fill in this gap here, okay, leaving over here. And now this other electron in the s is going to go away. That's the electron that's lost to make a silver ion. Okay, so with transition metals, losing the entire s orbital is okay, especially if it means that the d orbital or the f orbital is either all the way full, as you see there, or half full. An example where it might be half full, let's look at ruthenium, which is Ru. Okay, Ru has 2 electrons in the s, and then it has 6 in the d. And again, this could work similarly for an f orbital. Just half full would be 7, full would be 14. So ruthenium, 2 in the s, and then 6 in the d. So there's 1 paired, and then there's 4 ups. So the d orbital, in this case, it's not really close to being full. It would need 4 more electrons, and it can't just, bump up the s to get 4 more, because 2 doesn't equal 4. So this time, ruthenium is going to lose electrons. Now, as ever. So there are a couple of different ways that ruthenium can lose electrons. The first thing that can happen, since the d shell is close to being half full, they can lose this one, making it half full. And if the d subshell is half full, generally the s will also become half full. Okay, so that would mean that ruthenium would lose 2 electrons, 1 from the s, 1 from the d, and everything would be half full. And that's a pretty stable situation again. The ruthenium can have 2 charges, like a lot of transition metals can. So the other thing that might happen is it might just lose the s entirely. Okay? So both of the s electrons plus that 1 paired electron in the d might be lost as well. So the 2 options for ruthenium are 2+ and 3+. So draw out your electron configurations, just the last row of the electron configuration is fine, and just kind of like move electrons around to make the d or the f either full or half full. But remember, you can only do it by losing electrons, because all of these things that we're talking about are metals.